In the last class, I have explained you about the technical terms related with simple machines, about the fulcrum, effort arm, load arm, mechanical advantage, velocity ratio, efficiency. So these are the things I have explained you in the previous class. Okay. Now today we will solve some numericals based on these technical terms, how to find mechanical advantage, okay, how to find effort, how to find load, okay. So these things I'll show you, okay, I'll show you the work, how to solve. And before that, I'll explain you about the idle machine and the practical machine and the principle of lever. Okay, these things I didn't explain in the last class. So try to understand about the idle machine and the practical machines. Okay. Now the two types of machines are there. One is the idle machine. Now idle machines are those machines in which there is no loss of energy, in which the work output is equals to work input. Okay. So we know that work input and the work output, you know that. Work input means work done on the machine. Work output, work done by the machine. So in case of a idle machine, okay, the work done on the machine will become equal to work done on the machine. That means the work done by the machine is equal to work done on the machine. So that means there is no loss of energy. There is no loss of energy. I'll give you one example. Suppose you purchase a machine, one device, okay. Let us consider a car. Now you purchase a car and you don't ride, okay, you don't ride a car. That means you keep it in one place, you keep it fixed at one place, okay. So 1 month, 2 months, 3 months, and so on. You don't ride it or you don't use it, okay? You don't start or you don't travel anywhere, okay? You keep it in one place. After a year, after many years, what will happen? That car, the machines of that car are no longer in use. The rust starts occurring. Okay, the battery goes down. The vehicle or the car doesn't start. Okay, the tire also get punctured, and finally that car will of no use at all. It is of no use because you are not using it. Okay, if you don't use the car, there is no loss of energy. There is no loss of energy, and always the energy is lost in the form of heat as well as sound, because some friction is produced there. But if you don't use that car or any device, if you don't use it, okay, after many years, okay, that the device will become useless. Okay, they get spoiled. So that kind of machine we consider as a idle machine. We call it as idle machine. So in idle machine, there is no wastage of energy, okay, and the work input will become equal to the work output. But whereas in a practical machine, the machine which are always in a constant use, this type of machine we call it as a practical machine. Okay, and also in the idle machine, the efficiency is always 100% because there is no loss of energy, and no machine has got efficiency 100%. Remember that. No machine has got efficiency 100%. Okay, the machine which are in use, always the machine, they lose energy due to the friction of the moving parts. You know the friction. The friction occurs when the two surfaces of the body comes in contact with each other. Okay, so an idle machine, always the efficiency is 100%. Now let us come to the practical machine. The machine which we are always in use when you purchase a TV or any type of electronic gadgets or a car or anything, any device, any machines you purchase it. What do? You will use that machine. Okay, you will buy a refrigerator. You use that refrigerator. You purchase a TV. You watch TV. You switch it on. Okay. Every day you watch television. You purchase a car. Okay. Whenever it is necessary, whenever it is required, you ride a vehicle. You ride a car. So that means these machines are always in use, which we call it as a practical machine. Okay. And practical machine always. The efficiency of the practical machine is always less than 100% because there is always a friction when these machines we use it. There is a friction between the moving parts of that machines and the energy is wasted, or we call it as a dissipated. The energy gets dissipated in the form of heat and sound energy. Okay, example again. If you ride a vehicle. Okay, what will happen in the engine of the vehicle? The engine of the vehicle gets heated up. It produces sound. And how that engine gets heated up? Because of the friction between the moving parts of the vehicle. So that we call it as an idle machine. And the idle machine, the efficiency of the idle machine is never 100%. There is always less than 100%. That means 10% of energy get lost due to the friction of the moving parts. Okay, and that energy gets wasted in the form of heat and sound energy. So that we call it as a practical machine. So whatever the machine which we use nowadays, that means the machine which we use, all these are the practical machines. So this is about the idle machine and the practical machine. And next one comes the principle of lever. Okay, suppose you take a lever. A lever is a straight or a bent bar. Okay, last time I told you, a lever is can be a straight or a bent bar which is fixed at one point called the fulcrum. So let us consider this as lever. Okay, now this lever, when you fix the fulcrum, that means when you fix a nail at the center, at the middle. Okay, now this lever will remain stable. It will be balanced. It will be balanced. So if you fix a nail here, what will happen? This part will come down. Again, if you fix here, again this part will come down. Again, wherever you at some portion here, not at the center, but somewhere away from the center. When you fix some nails or some support, okay, what will happen to the lever? The lever doesn't get balanced. Balanced means it should remain straight, but the lever doesn't remain straight here. Okay, when the lever will remain straight? When you fix a nail at the center. So that is the fulcrum we call it. Okay, so regarding with this condition, okay, so when the lever is said to be in a balanced condition, okay, when the lever is said to be in a balanced condition, the lever is set in a balanced condition, okay, when the load and the load arm is equals to effort and the effort arm. That means load and when the lever get balanced, okay, load into load arm equals to effort into effort arm. Okay, now when this will become equal, load into load arm will become equal to the effort and the effort arm, then what will happen? The lever get balanced. And this is known as the principle of lever. This is known as the principle of lever. Okay, so now when you solve these numericals, okay, you can find mechanical advantage, you can find load, you can find effort, okay. And if the load arm and effort arm is given, okay, you can use the principle of lever also. So this is known as the principle of lever. So this principle of lever states that the lever will be in the stable equilibrium, that means the stable condition when the load and the load arm will be equal to effort into effort arm. Okay, so now this principle lever is very important when you solve the numericals. Now next one, let us come to the numericals. Few numericals, I will show you how to solve it, which is based on simple machines. So now number one, the first question is a load of 120 Newton. There is a load, okay, and the load is 120 Newton is kept at a distance of 1.5 centimeter from the fulcrum of a lever. Okay, so there is a lever here, okay, and there is a load. Load is 120 Newton. And this load is kept at a distance of 1.5 centimeter from the fulcrum. Suppose let us consider this as fulcrum here. Okay, that means 1.5 centimeter from the fulcrum. Sorry, 1.5 meter from the fulcrum. Okay, then at what distance an effort of 40 Newton be needed? That means this is the effort is given here, 40 Newton. So what distance means you have to find the effort arm. At what distance you have to find the distance so that this lever will come in the state of equilibrium. So that means it remains in the state of balanced state. Okay. So already the load is given. Load arm, this is the load arm. Okay. Load arm is given. Effort is given, and you have to find the effort arm. Okay. So after calculating the effort arm, then in that case, load into load arm equals to effort into effort arm. So at what condition after finding the effort, okay, when the lever will become in the balanced state, you have to find it. So the first question, to understand it, this is the way you have to understand. Okay. Now I'll write it here. The first one, load is given. Load is given 120 Newton. Okay, then load arm is given. Load arm equals to 1.5 meter. Then effort is given. Effort is given 40 Newton. Then we have to find effort arm. Effort arm is question mark. Now from the principal lever, we know that from the principal, P-R-I-N-C-I, principle of lever, you know that load into load arm equals to effort into effort arm. Or you can write it effort into effort arm because you are finding effort arm. So whatever you have to find, you have to write it on the left hand side. Okay. So I am writing it, instead of writing load into load arm, I am writing it effort into effort arm equals to load into load arm. So this is the principle of lever. Okay. Now first with the value. What is the effort here? 40. What is the effort arm? You don't know effort arm. Okay. Effort arm, you keep it as it is. Equals to what is load here? 120. What is load arm here? 1.5. Okay, 1.5. Now calculate load arm, effort arm, sorry. Effort arm equals to 120. 120 into 1.5 divided by 40 equals to, remove the decimal here, 15 you can make it here, 40 you can make it here. Okay, so you have removed the decimal, so I am writing the 10. Then 5 2s are 10, 5 3s are 50. Okay, this 0 0 cancels it. Okay, 4 1s are 4, 4 3s are 12 equals to 3 3s are 9 by 2 equals to, now divide it here, 2 4s are 8, 2 5s are 10, so equals to 4.5 meter. So this is the effort arm. Okay, so after finding the effort arm, so therefore now the effort arm is 4.5 meter. Okay, now you can say that the lever is in a stable equilibrium. So this is the first answer. So the first question answer.